Dear colleagues, laboratory Sтэхо represents to your attention the electric energy-saving device. This device is designed for electric power amplification without power drain from the additional power supply. And such units are used in this system. Three-phase power amplifier of 10 kW. The maximum power of this device is about 25 kW. The electric incandescent lamps of 500 watt each are used as an active load. So the total summary load is 10 kW. 3 watt for each phase. As measuring instruments, we use two common counters.
Трехфазные, прямого включения, как вы видите. Счетчики одинаковые. Значит, один счетчик.
The first counter measures the parameters of physical activities from the circuit.
Параметры потребляемые сети, физических величин, то есть всех силы тока, напряжения и так далее. Второй счетчик.
The second one measures the parameters in the load circuit. As you see, voltage is connected with the help of 4-branch cable, 3 phases and 0.
Питающий кабель подходит. Заводится сразу на прибор учета. С прибора учета напряжение подается на устройство.
Then it is connected to the measuring instrument, and from the measuring instrument voltage runs to the device, and after it to the second measuring instrument, and then to the load.
Про подпольник скажи, что-нибудь еще.
Сразу хочу
We'd like to assure you, dear colleagues, that this device doesn't use any additional wires or cables.
Вы видите, что по ножкам лавки, лавок никаких кабелей не подходит, не подводится. То есть никаких дополнительных питающих кабелей, проводов у нас нет.
Let's begin our experiment. Let us demonstrate you the principle of its functioning. So we are switching the device and fixing the primary reading. The registration at the input. Let us start from the active power. The power in the first phase is 480 watt. In the second phase we have 360 watt. In the third phase we have 400 watt. The total active power is 1260 watt. And now the reactive power. In the first phase, 1100 varus. In the second phase, 890 varus. In the third phase, 1000 varus. The total reactive power is 3000 varus. The full power consumption. The first phase is 1200 volt ampere. In the second phase, 1000 volt ampere. In the third phase, 1160 volt ampere. And total full power is 3300 volt ampere. Voltage in the first phase is 207 volt, in the second phase 201 volt, and in the third phase is 196 volt. And now current intensity. In the first phase is 5.7 ampere, in the second 4.8 ampere, and in the first phase is 5.9 ampere. These are registrations of the measuring instrument at the input, so what we have from the circuit. The device at the output measures the following registration. The active power in the first phase 3600 watt. In the second phase 2800 watt. In the third phase 2650 watt. Total active power 9000 watt. The reactive power in the first phase is 75 varus. In the second phase is 40 varus. In the third is 45 varus. The total reactive power is 163 varus. And now the full power. In the first phase it is 3600 volt ampere. In the second 2800 volt ampere. In the third 2600 volt ampere. The total full power of the load is 9100 volt ampere. The voltage in the first phase is 220 volt. In the second is 230 volt. And in the third is 220 volt. The current intensity in the first phase is 16 ampere. In the second phase is 12 ampere. And in the third phase is 12 ampere. So we can see that as the result of transformation of the reactive power into active one, we get the amplification of the clear active power in 10 times, and the amplification of the full power in 3 times. The action of this device is founded on the reactive power using. That is, the reactive power is reinforced with the help of the resonance, and then with the help of this device is transformed into the active power. The power delivery from the resonance circuit is effected without disturbance of its parametric nature.